Deal today. I'm going to do the first one with you, and then you're going to do the next one on your own. Hey, check it over, and I'll give you the okay to go on to the next one. All right, just to make sure we know what we're doing all by ourselves. All right, let's start it off here. You guys see the proof statement, so that ticks me off here. Hey, I got to do it indirectly. So get your statements reason set up, get your givens, and I'll ask somebody here in a second what's going to be your assumption here. Actually, why does this look? Didn't we just go over this one? This is the one we just went over on homework, wasn't it? Abbott just asked this one, right? We prove these two triangles congruent by side angle side, and then we say CP/CTC. We already went over this one, didn't we?
Not exactly. The other one was BD not perpendicular days. Oh wait.
That's what it says. All right, let's go. I'm not going to waste the time then. Let's go to 2. All right, let's go to 2. Sorry, I didn't notice that. Okay, what's your assumption here? Let's start there. What's our assumption? Three. What's our assumption, Spence?
AE.
Good. AE congruent to CD. There's our assumption. Remember, use that as a given now as well. All right, before we just start writing down some random stuff and hopefully it comes together at the end, let's look at our two givens right here. Triangle ABC is scalene, and I have altitudes AE and CD. Somewhere in your proof, you are going to prove the opposite of one of those two. You're going to contradict one of those two. So let's talk here before we start the proof. Which one is it going to be easier to contradict? ABC is scalene or altitudes AE and CD? Well, if triangle ABC is scalene, how can you contradict that? By saying it's? Okay, but not scalene, but give me another term. Not scalene, it could be what? Isosceles. Everyone agree? If I can show that triangle ABC is isosceles, that contradicts the statement that it's scalene. We all agree? Okay, let's do it. Somewhere here. So again, here's our goal. Somewhere in our statements, I don't know which step it's going to be, but we're going to write down triangle ABC is isosceles. You guys have to help me get there now. How do I make triangle ABC isosceles? Well, I can prove two what congruent? Sides or angles congruent. Let's just go sides. All right. So can you help me get AB, side AB congruent to side BC? That's what, if you can do that, it's going to be isosceles and we have a contradiction. So how do I get AB congruent to BC? We already know AE and CD are equal. All right, I have altitudes. What do altitudes form? Right angles, okay. How am I going to get AB congruent to BC? What am I going to have to prove congruent first? Yeah, this is going to be like a CP/CTC. Can you pick two triangles that contain AB and BC? They overlap each other, so we're going to have to do a little highlighting, but everybody see them? The two triangles that contain AB and BC, name them for me. Two triangles where AB is a full side and BC is a full side, so I can highlight them.
BEA
Okay, here we go. Here's the first triangle right here.
and BDC.
And this one right here that overlap each other. Okay, you guys prove those two congruent, my sides will be equal. Agreed? And remember, we already have AE congruent to CD. That was our assumption. So we got a pair of sides already. We have a pair of sides right here. If you want to mark that, great. If not, fine too. I got a pair of sides. What did we just say the altitudes do? 11, what do altitudes do? Not here. 7, what do altitudes do?
Form right.
So I have a right angle right here. AE is an altitude, and so is C. Oh, sorry, wrong. Yep, CD right here. There's my other right angle. Everyone agree? All right, we got to put that in the proof that they're right angles. Angle BEA congruent to angle BDC. I'm sorry, you guys say the right. I'm on fire today. To say the right angles. BEA and BDC are right angles. I can't write perpendicular lines form right angles though. I didn't have that symbol there at all. What can I write instead? How do we know they're right angles? How do we know to put right angles there? 6. Altitudes form right angles. I like it, Nate. Definition of an altitude, either one's fine. Then you can say they're congruent. Angle BEA congruent to angle BDC. That's all right angles are congruent. There's your A. So I have a pair of sides and a pair of right angles now. Where's the other pair? I need one more pair to prove them congruent. I got the right angles and I got the sides. Anybody see the other pair here? Dig deep, dig deep. Where's my other pair that I can say are congruent here? Who's got this? 7?
A, B, E is congruent to. Would it be A, E, B, or A, B, E?
Same angle, right?
Yeah.
Everyone see this full angle here is shared by both triangles. Reflexive, so angle B congruent to itself. Yeah. It's going to be a long proof. Reflexive, and there's your other A. It's just a matter of angle, angle, side, or angle, side, angle. You guys have to determine if that side's in between or not. Best way to do it, draw one out and mark the side and the two angles. Draw it out, and mark the angles and the side. Triangle, what do we got here? BDC. Congruent to triangle BEA. Is that side in between or not? I don't think it is if you draw it out. So we're going to go angle, angle, side. And there was a reason why we proved the triangle's congruent, because what sides do we want congruent now? 5. What sides do we want?
A, B, and BC.
There you go. AB congruent to BC. CPCTC. And what type of triangle is it now? If AB and BC are equal, what type of triangle do I have for ABC? 9? Isosceles. So ABC is isosceles. Why? Why is that? How do we know it's isosceles? 13, how do we know this is isosceles? What did we just prove?
The two opposite sides are congruent.
So here you go. In a triangle, two sides congruent implies I have an isosceles triangle. And then what do you have written down on your paper right now? Given, say, it's a scalene, we just proved that isosceles can both happen at the same time. Nope, that's a contradiction. So once the contradiction is written, once you prove the contradiction, we're done. The assumption was false. So the opposite is true now. AE is not equal to CD. Assumption led to contradiction. One indirect proof on the test Friday. One indirect proof at the end. And what lines were the contradiction fall? 9, what lines? And where do we contradict it? Because we said triangle ABC scalene in step 1. Where do we contradict that? 8, that it was isosceles. Those two cannot happen. Okay, go to 3. Call me over when you're ready, or if you get stuck. Okay, go to question 3. Call me over when you're ready, or if you get stuck.